Nowadays, we see more and more hybrid or electric vehicles on the road. The advantages are cleaner air due to lower exhaust and fine dust emissions, as well as lower noise levels compared to conventional combustion engines. The core feature is the battery, which has to withstand high levels of stress. In particular, overheating must be avoided to guarantee a long and reliable service life. At Mahler-Behr in Stuttgart-Feuerbach, a specialist in automotive air conditioning and motor cooling systems, creative brains are working hard to develop innovative solutions for tomorrow's vehicles. In this context, modern measuring systems and thermal simulations are used. In the Central Advanced Engineering Department, components are developed which make intelligent use of thermal interface materials to optimize thermal management. The battery must have a good thermal connection with the cooling plate. At the same time, electrical high-voltage insulation is necessary. This can be achieved using highly effective thermal interface material, suitably placed between the battery cells and the cooling plate. The cooperation between Mahler-Behr and the Steinbeis Transfer Center for Heat Management in Electronics resulted in a new test rig for characterizing innovative interface materials.
Lithium-ion batteries are very sensitive concerning the temperature and the thermal gradient which can appear during the operation. So you need a very effective thermal interface in between the battery cells and the cooling device to have a very good thermal management, and then you can get a very, very good lifetime and a very high performance of the batteries. With this test rig now we are able to determine the material properties of the thermal interface very exactly. Like that we'll be able to get a benchmark for the automobile industry.
A sample is placed in the measurement section between two reference materials. The upper part of the measuring system is heated and the bottom side is cooled. In this way, the sample is exposed to a one-dimensional heat flux. Using a hydraulic unit, the sample can be compressed according to its elasticity. The surface pressure can be precisely adjusted using the controlling software. At the same time, an LED micrometer measures the thickness of the sample with high accuracy. Numerous calibrated thermocouples record the temperature curve along the heat path. This is used to calculate the heat flux and thermal resistance of the sample using the evaluation software. In addition, the thickness shift of the elastic samples can be investigated over time.
Crucial factors are homogeneous surface pressure, as well as the determination of heat flux and its uniformity with precise temperature measurements. In addition, controlled long-term studies are possible. So, the new design enables us to investigate the thermomechanical characteristics at a significantly improved level of measuring accuracy and repeatability.
At the Baden-Württemberg Cooperative State University, Stuttgart, Professor Andreas Griesinger and his team from the Steinbeis Transfer Center are working on heat management in electronics, bridging the gap between science and application. Over a half-year period, the teams from Steinbeis and Behr have pooled their expertise.
Our cooperation with Behr was highly constructive and candid. Two teams of experts cooperated very closely and both partners benefited from their mutual experience.
The jointly developed test rig for characterizing interface materials proved to be valuable not only for Mahler-Behr. Students from the Cooperative State University also benefit from this innovation through laboratory tutorials and assignments. This allows them to gain practical experience using state-of-the-art measuring technology. In a further step, Mahler-Behr studies the thermal behavior of the whole battery module. A critical objective is to achieve a low temperature gradient within all the cells and, at the same time, a low interface resistance. At a final meeting at the university, the team's most important findings and results were summarized. Professor Griesinger and his team are already working on further innovative measurement systems. Using a new test setup, Thin layers measuring only a few micrometers are being characterized with the help of thermal waves. With this project, the partners have been able to demonstrate how innovative technologies and, consequently, competitive advantages can be created through the cooperation of science, universities and industry. New projects concerning aging behavior and reliability of thermal interface materials are being planned.